+1 ਮੈਡੀਕਲ ਐਂਡ ਨਾਨ ਮੈਡੀਕਲਸ ਦੇ ਪਿਆਰੇ ਵਿਦਿਆਰਥੀਓ, ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਤੁਹਾਡਾ ਮੇਰੇ YouTube ਚੈਨਲ ਫਿਜ਼ਿਕਸ ਕਨਸੈਪਟਸ ਐਂਡ ਮੋਟੀਵੇਸ਼ਨਲ ਟਾਕਸ ਬਾਈ ਪ੍ਰੋਫੈਸਰ I.S.Romana ਚ ਬਹੁਤ ਨਿੱਘਾ ਸਵਾਗਤ। मैं बतौर फिजिक्स प्रोफैसर प्रिंसीपल डायरैक्टर लगभग 35 साल ਵੱਖ-ਵੱਖ पंजाब के कॉलेजों के काम किया है। जो कुछ सीखिया उतों तो मैं सोचा अपनी रिटायर्ड लाइफ जो कि बहुत वधिया लाइफ मैं इंजॉय कर रहा तो तुहाडे नाल जो भी मैं सीखिया है वो शेयर करा। सो इस करके मैं एक कोशिश शुरू की है तो मैंने पूरी उम्मीद है कि मेरी एक कोशिश ये चैनल राही और ये वीडियोज़ राही तो जरूर फायदा देगी, क्योंकि किसी भी फील्ड में कामयाब होने या किसी सबजैक्ट को चंगी तरह समझने लई एक गाइड, एक मोटिवेटर, एक मैंटर की लोड़ होती है। सो मैं कोशिश कराँगा कि तुहाडा मोटिवेटर और मैंटर बन सका कि तुसी सबजैक्ट फिजिक्स को चंगी तरह समझ सको तो अपनी जिंदगी के विच सफल हो सको। किसी शायर ने कहा है कि मुश्किलें कुछ भी नहीं है इस दुनिया में, तू जरा हिम्मत तो कर। मुश्किलें कुछ नहीं है इस दुनिया में, तू जरा हिम्मत तो कर। ख्वाब बदलेंगे हकीकत में, तू जरा कोशिश तो कर, तू जरा कोशिश तो कर। सो मैं भी कोशिश कर रहा तो मैंने पूरी उम्मीद है कि मैं अपनी कोशिश के सफल होवांगा और तुहानू सफल होने दे विच थोड़ी बहुती मदद जरूर कर सकांगा। सो अज का टॉपिक है तुहाडा पहला चैप्टर फिजिक्स का यूनिट्स एंड डायमेंशनस। अज इस पार्ट दे विच फस्ट पार्ट दे विच मैं डिस्कस करूँगा सिस्टम ऑफ यूनिट्स। System of units, first of all, what is the need of measurement? Because what is physics? Physics is that branch of science which deals with the study of nature and natural phenomena. So if we have to study any natural phenomena, then we have to make measurements. For example, if we have to study motion of a particle, we have to measure its displacement, velocity, acceleration, force acting upon it, and all this is possible if we make measurements. So measurements play an important role in the study of physics. Then what do you mean by a physical quantity? Any quantity that can be measured accurately is known as a physical quantity. For example, mass, length, time, speed, velocity, acceleration, pressure, momentum, force. There are so many physical quantities. And to measure a physical quantity, we need two things. Number one, a unit, U. Unit means a standard used to measure a physical quantity. And number two is a number multiplier n. It tells us that how many times the unit U is contained in that physical quantity. So if Q be the magnitude of physical quantity, n is a number multiplier and U is the unit, then Q is equal to NU. Since magnitude of physical quantity must remain the same whatever may be the system of measurements, therefore if n1 is the number multiplier and u1 is unit in one system, n2 number multiplier and u2 is a unit in other system, then n1 u1 must be equal to n2 u2. It means nu remains constant, product of number multiplier, and u remains constant. It means if u1 is greater than u2, n1 should be less than n2 and vice versa. It is bigger is the unit, smaller is the number multiplier. For example, we take mass 1 kg is equal to 1000 gram. So kg is bigger than gram. Therefore, number multiplier of kg is 1 and number multiplier of gram is 1000. Similarly, time is measured in second. 1 hour is equal to 60 minutes or 60 into 60 seconds. So number multiplier depends upon the size of the unit. Then what are fundamental units? Now again, what is the need of these fundamental units? Because in physics we deal with large number of physical quantities, and each physical quantity requires at least one unit, maybe more than one. It means there will be large number of units, and it is very difficult to remember all these units. So that's why we choose some basic set of fundamental units, and we derive all other units using these fundamental units. So no need to remember all the units. So the basic units of mass, length and time, denoted by capital M square bracket, capital L within square bracket, capital T within square bracket. They are known as fundamental units of mass, length and time. And mass, length and time are known as fundamental physical quantities. So why they are called fundamental? Because they are so simple and which cannot be further separated into one or more simpler units. And moreover, everybody knows about mass, length and time. Even the person who do not know physics knows about mass, length and time. So they are basic, fundamental. That's why they are called fundamental units. Then derived units. The units which are derived using fundamental units are known as derived units. For example, speed. Speed is equal to distance upon time. Distance is taken as length, time t capital. So we solve it. It is m0 L1 t minus 1 within a square bracket. Because anything raised by 0 is 1. M is not here. Even so we write m power 0. To give it complete form of all fundamental units m, l and t. Then what do you mean by dimensions of a physical quantity? So dimensions of a physical quantity are the powers like 0, 1, minus 1, to which the fundamental units of mass, length and time must be raised to express its units completely. So in this case 0, 1, minus 1 are dimensions of speed, that is 0 in mass, 1 in length and minus 1 in time. So 0, 1, minus 1 are known as dimensions of speed. Then what is the dimensional formula? So dimensional formula is an expression which tells us how and which of the fundamental units of mass, length and time are needed to express the units of the physical quantity completely. Well, what are the powers given to m, l and t, and which fundamental units are chosen? So it describes dimensional formula. So for example, right hand side of this equation, that is m0 L1 t minus 1 within square bracket, is known as dimensional formula of speed. Then dimensional equation. When physical quantity is made equal to its dimensional formula, then the whole expression is known as dimensional equation. For example, speed is equal to m0 L1 t minus 1 is known as dimensional equation for speed. It will give its units, not numerical value. So then we come to system of units. Now we have two types of system of units that we usually use. One is c.g.s system, centimeter, gram, second system, in which length is measured in centimeter, mass in gram, time in second. Number two, SI system, length in meter, mass in kilogram, time in second. But it is old MK system. When we have SI system, that is International System of Units, it has 7 fundamental units instead of 3. Length meters, mass kilogram, time second, current in ampere, temperature in Kelvin, luminous intensity in candela, and quantity of substance in mole, or quantity of matter is measured in mole. So these are the 7 fundamental units in SI system. It also has 2 supplementary units. Number 1, radian. What is radian? Suppose we have a circle of radius r, center O. Let an arc of length L. Theta is the angle subtended by this arc at the center of circle. Then by definition of angle is equal to arc upon radius. Or when this length of arc becomes equal to radius, then that particular angle theta is known as 1 radian. So radian is the unit of plane angle, and angle subtended at the center of circle is said to be 1 radian when length of arc is equal to radius of the circle. That is, 1 radian is the angle subtended by an arc whose length is equal to radius of the circle. So, total angle around a center of the circle is equal to 2 pi radians. In degrees, it is 360 degrees. Therefore, 360 degrees is equal to 2 pi radians. So, we can convert degrees into radians or radians into degree. So, 1 degree will be pi radians. So, radian is the unit of plane angle, and it is one of the supplementary units of SI system. Then, what is steradian? Second unit. So, steradian is the unit of solid angle. It is a 3-dimensional angle. So, it is the angle subtended by a cone that we use to eat ice cream. So, angle subtended by the circular part of cone that is used for to eat ice cream at the edge of the cone. So, is known as solid angle. So, solid angle is the angle subtended by certain area. So, suppose a sphere of radius r and center O. Let ds is the area which subtends an angle omega. Omega is the symbol used to note solid angle. So then by definition, omega, that is solid angle subtended at the center of sphere by area ds having radius r is given by omega is equal to ds upon r square. When ds is equal to r square, then omega is equal to 1 steradian. So 1 steradian is the unit of solid angle, that is 3-dimensional angle in SI system, and angle subtended at the center of sphere is said to be 1 steradian when area becomes equal to square of the radius of the circle. So total angle subtended at the center of the sphere is equal to 4 pi steradians. Total angle subtended at the center of circle is equal to 2 pi radians, but total angle subtended at the center of sphere, that is 3-dimensional angle by whole area of the sphere, is equal to 4 pi steradians. So these are the 2 supplementary units, radian and steradian. So you can remember the definitions. Then advantages of SI system over c.g.s system, because we have studied SI system and c.g.s system. Now, why we prefer SI system over c.g.s system? There are so many advantages of SI system over c.g.s system. Number 1, SI system is a coherent system. Now, what do you mean by coherent system? So, coherent system is that system in which all the derived units can be obtained from a certain set of basic units, that is fundamental units, by simply multiplying or dividing them without introducing any numerical factor or factors. So such a system is called coherent system. So for example, just like c speed, simply L upon T. So we have used only fundamental units, no numerical factor, no numerical value. So such a system is known as coherent system of units. So SI system is coherent, so that's why we prefer it over c.g.s system. Number 2, it is absolute. So absolute system because no involvement of acceleration due to gravity. So value of G doesn't involve in units in SI system. That's why it is known as absolute system. Then it is a decimal system or a metric system. Decimal or metric system means all multiples or sub-multiples can be expressed to the power of 10. So it is easy to remember these multiples and sub-multiple units. So it is a metric system or decimal system. Fourth is, it is rational system. Rational system means it has only one unit for a given physical quantity. For example, joule is the unit of energy. Whether it is chemical energy, it is magnetic energy, it is sound energy, it is light energy, it is potential energy, it is mechanical energy, it is kinetic energy. So all types of unit energies are measured in joule. So such a system is known as a rational system. And last advantage is it is internationally acceptable. So there are 5 advantages of SA system over c.g.s system. I repeat, it is coherent system, it is absolute system, it is decimal system, it is rational system, and it is internationally acceptable. So it is known all over the world. That's why SA system is preferred over c.g.s system. Now, another question, the same question may be asked in this form. What are the characteristics of a desirable standard or unit? एक यूनिट या यूज करते हैं ਅਸੀਂ ਉਹਦੀ ਕੀ ਕਰੈਕਟਰਿਸਟਿਕ ਕੀ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ? नंबर 1, it should be well defined. ਉਹ यूनिट well defined ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ. नंबर 2, it should be of suitable size. ਨਾ ਬਹੁਤਾ ਵੱਡਾ ਨਾ ਬਹੁਤਾ ਛੋਟਾ. It should be easily reproducible at all places. It should be available everywhere whenever required. Fourth is, it should be independent of secular changes. That is, change in pressure, temperature. It should not change with the passage of time. So it should be independent of secular changes. And last is, it should be internationally acceptable. So these are the 5 characteristics of a physical standard that we use to make measurements. That's why we use M, L and T. So same question, why we choose mass, length and time as standard units or to know the units of all physical quantities? M, L and T are the basic units or fundamental units. So same answer, because they are well defined. Everybody knows about mass, length and time. They are of suitable size. They are easily reproducible at all places. They are independent of secular changes. Mass, length, time doesn't change from place to place. And fifth is, they are internationally known, internationally acceptable. So this is all about system of units. It is first part. In second part, I will discuss dimensional formula and their applications in physics. So उम्मीद है ਤੁਹਾਨੂੰ ਮੇਰਾ ਵੇ ਆਫ ਟੀਚਿੰਗ ਵਧੀਆ ਲੱਗਿਆ ਹੋ। ਜੇ ਥੋੜੀ ਬਹੁਤੀ ਪ੍ਰੋਬਲਮ ਵੀ ਹੋਵੇ ਤਾਂ ਪਲੀਜ਼ ਇਹਨੂੰ 1 ਜਾਂ 2 ਵਾਰ ਦੇਖ ਲਿਓ ਔਰ ਇੱਕ ਕਾਪੀ ਪੈਨ ਲੈ ਕੇ ਨੋਟਸ ਬਣਾ ਲਿਓ। ਜੇ ਤੁਹਾਨੂੰ ਨੋਟਸ ਵੀ ਚਾਹੀਦੇ ਨੇ ਤਾਂ ਤੁਸੀਂ ਮੈਨੂੰ ਕਮੈਂਟ ਬਾਕਸ ਜਾ ਕੇ ਕਮੈਂਟ ਕਰ ਸਕਦੇ ਹੋ ਤਾਂ ਮੇਰੇ ਨਾਲ ਕੰਟੈਕਟ ਕਰ ਸਕਦੇ ਹੋ, ਆਪਣਾ ਨੰਬਰ ਦੇ ਸਕਦੇ ਹੋ, ਮੈਂ ਤੁਹਾਨੂੰ ਕੰਟੈਕਟ ਕਰਕੇ ਤੁਹਾਨੂੰ ਨੋਟਸ ਵੀ ਪ੍ਰੋਵਾਈਡ ਕਰਾ ਸਕਦਾ। ਸੋ ਖੁਸ਼ ਰਹੋ। ਜੇ ਤੁਹਾਨੂੰ ਮੇਰੀ ਵੀਡੀਓ ਵਧੀਆ ਲੱਗੀ, ਪੜਾਉਣ ਦਾ ਤਰੀਕਾ ਵਧੀਆ ਲੱਗਿਆ ਔਰ ਮੋਟੀਵੇਸ਼ਨਲ ਗੱਲਬਾਤ ਨਾਲ ਨਾਲ ਪੜ੍ਹਾਈ ਦੇ ਵਧੀਆ ਲੱਗੀ ਤਾਂ ਪਲੀਜ਼ ਚੈਨਲ ਨੂੰ ਜ਼ਰੂਰ ਸਬਸਕ੍ਰਾਈਬ ਕਰ ਲਓ, ਬੈਲ ਆਈਕਨ ਤੇ ਕਲਿੱਕ ਕਰ ਲਓ ਤਾਂ ਕਿ ਤੁਹਾਨੂੰ ਨੋਟੀਫਿਕੇਸ਼ਨ ਮਿਲਦੀਆਂ ਰਹਿਣ। ਲਾਈਕ ਕਮੈਂਟ ਜ਼ਰੂਰ ਕਰੋ, ਆਪਣੇ ਵਿਚਾਰ ਜ਼ਰੂਰ ਦਿਓ। Be happy, stay tuned for next coming video. Thank you, be happy, all the best and good luck.